Good afternoon, my YouTube viewers. It's Crystal here, and I wanted to make another video for you on hypothesis testing. This particular hypothesis test we're going to be looking at is a F-test in Excel. So we're going to be checking two samples. So this is the observed. This is what we have observed, and it's going to be random numbers between 0 and 100. And it's going to be 20 random numbers. And this is what we expected, which is going to be another random number, but we're going to use rand, and rand gives you a number between 0 and 1, and we're going to multiply that by 100. So ultimately, you would be getting another random number between 0 and 1. But in the observed column, it's an integer, and then in the expected column, it's a float. So we're going to set our alpha. You can set your alpha to anything that you want. So we'll just reset it to 0.05, making it 5%. And then we check the mean for sample number 1, which is the average of A3 to A22. And then the mean for sample number 2, which is the average of B3 to B22. And so you've got a big disparity. You've got 9 points, 9 numbers between 40 and 49. So the means are different. And then we're going to check the variance. So we're going to check the variance of the sample from A3 to A22 using var.s for sample 1 or observed. And then for the expected, we're going to be checking the variance for B3 to B22. And we're going to be checking the variance of a sample. We're going to check the p-value, and on the p-value, it's going to be F-test, and then A3 to A22 and B3 to B22. And the p-value is 0.4, so that makes it true. But it's still quite a big difference between the observed and the expected. So let's just change this to 0.1 and see what happens. And so it's still, with 0.1, you still accepts the null hypothesis. So let's just check 0.5 and see what happens. And since you have a big p-value, you've got a big p-value, so it's about a 3% difference. So let's just check this, what's expected. So we'll say 50. We're going to want to change the number so we'll get a false. So again, we've got a false here because we've got, on the observed, we've got a mean of 49, and on the expected, we've got a mean of 26. So it gives you a very low p-value of a false. So we'll take it back to the 5% range, and it's still got a false on the 5% range. So what I'll do is I'll take this back to 100, and then so you can see how the means, if you can see how if the means change, then it's going to affect the p-value, which is, we're going to be using the F-test on the p-value. And then we're going to check the null hypothesis. That means E7 is going to be greater than E2, and E7 is your p-value. So that means your p-value has to be greater than the alpha or the significance level. Your alpha is your significance level. So that this just shows you how if the means change or the variance change, then the null hypothesis is going to change. Because right now we have a null hypothesis saying that the means are the same. But in the previous example, when we changed the expected from 100 to 50, then we got a false null hypothesis, which meant the means of the two samples were not the same. So you had to accept the alternate hypothesis. And the alternate hypothesis is that the means are not the same. So that's it for this particular video, because we've covered the F-test, we've covered the alpha, the significance level, the means of the two samples, the variance of the two samples, p-values, the null hypothesis, and we've also discussed how to create random numbers to make your data, to make some fake data, so you can run tests and experiments and things like that. So I'm going to go ahead and close this video. If you like my video, please like, subscribe. Thank you so much for watching my video, and I look forward to making another video for you in the future.